Hello there. Let's talk about math. Specifically, we are right in the middle of chapter 7, talking about congruence and similarity. And we've already talked about congruence and what that means. In fact, just as a little bit of a review, when you do a translation of a figure, the image is congruent to the pre-image. You have congruence there. And with a reflection, you also have congruence. And with a rotation, you also have congruence because in all of these cases, the new image is congruent to the original pre-image. Okay, congruent, they're the same, they're matching. But what about when you do a dilation? When you do a dilation, we don't have congruence anymore. Now, the pre-image and the image are similar. Similar figures are the same shape but different sizes. So they're not congruent, they're not matching, they're not exact replicas of each other. They're similar, same shape, different sizes. So some other words that kind of go along with that are the ideas of enlarging something or reducing something. In other words, making it a grow, expanded, bigger version or a shrunken, smaller version. But it has to be to scale or it has to be proportional to the original pre-image. So here's a test. Is it the same shape and is it a different size? If yes, then it is similar. Like these two shapes. Are these two shapes similar? Are they the same shape? Yeah, they're both regular octagons. Are they the same size? No, but that's what they're supposed to be if they're similar. So these two shapes are similar because they're the same shape, but different sizes. Okay? Are these two figures similar? Yeah, they're the same shape of a pentagon, but they're different size. They're not congruent, but they are similar. What about these two triangles? Are these two triangles similar? No, they're not even the same shape of a triangle. One's a right triangle and one's an acute triangle. These aren't similar. They're just two different triangles. Okay, and then, yeah, these aren't similar either because they're just two different kinds of rectangles. They're not like bigger or smaller versions of each other. They're not enlargements or reductions of each other. They're just two randomly different rectangles. So no, these aren't similar because they're not the same shape. Okay, these two triangles look like they might be similar. How can we tell if they're exactly the same shape? Well, we would have to put it to the test to see if they're to scale, to see if they're proportional. So if I look at MN, which is 32, and I look at the corresponding part JK, which is 24, and I make a ratio, is that ratio going to be equal to NO, which is 20, over KL, which is 15, and then the other two corresponding sides, which are 24 and 18. Well, in this case, if you reduce all of these ratios or fractions, you get 4 over 3, and then you also get 4 over 3, and then you also get 4 over 3 again. So are these two figures similar? Yes, they're similar because they're the same exact shape. They're proportional. They're just different sizes. Let's try another one. These two trapezoids look like they might be similar, but the only way to tell is to put it to the test. So we're going to do 10 corresponding to 4 and see if that's equal to 5 corresponding to 2, and then see if that's equal to 20 corresponding to 8, and then see if that's equal to the 7 and the 3. So then we just reduce all of these. 10 over 4 reduces to 5 halves. 5 over 2 already is in simplest form. 20 over 8 also reduces to 5 over 2. We're looking pretty good, except, 7 over 3. It's not the same ratio. It's not proportional. So are these two figures similar? No, those are not similar figures because they're not proportional. Okay. You can also tell if two figures are similar if one can be transformed into the other with geometric transformations, like reflections, rotations, translations, and dilations. So if we take triangle EDF and we dilate it, and then we translate it, hey, that gives us similar figures. So yes, those two triangles are similar because the image was a result of doing geometric transformations to the pre-image. Here's another example. Are these two rectangles similar? Kind of hard to tell. Let's find out. We'll take the original and we will rotate it, and then we will dilate it, and then we will translate it. Yes, we have similarity. And you can tell because that figure was the result of a series of geometric transformations that included a dilation, which gave us the same shape but a different size. That's all we have. So, see you tomorrow.